Hello everybody, how are you? Not sure you're doing very well. Today channel we're going to continue our lesson about changes of state. So last time we have discussed about change of state of matter, and we said that all matter undergo change in their physical state only when they gain or lose a certain amount of energy. And then we moved on, we discussed about melting and freezing, and we said that melting is when a substance change from a solid state into a liquid state, and freezing is the opposite process of melting, in which the liquid state will change into a solid state. So today our main question is, how do liquids and gases change state? So guys, for liquid, as a liquid is warm, its particle gain energy. So again, as we said, for any substance to undergo a physical change, it needs to gain or lose an energy. So as a liquid is warmed, the particles of this liquid will gain energy. This energy will be absorbed by these particles and will make these particles more freely to move around. So now some particles gain enough energy that they escape from the surface of the liquid and become gas, and this process is called evaporation. So evaporation, when the particles of liquid escape from the surface of this liquid and become gas. So here the state of this matter is changed from what? From a liquid to a gas, to a water vapor, for example. Okay, so again, evaporation is the process in which the particles of a liquid escape from the surface of this liquid and become a gas, and it will happen when you warm the liquid, in which the particles gain enough energy so they can escape. Okay, so guys, there is another important term that we need to understand, which is the boiling. Boiling is a rapid change from liquid to a gas or vapor. Okay, so maybe you may confuse between boiling and evaporation, but later, inshallah, later on in the next slide, we will explain exactly what is the difference between boiling and evaporation. Okay, so for boiling, again guys, is a rapid change from a liquid to a gas or vapor, and this change takes place throughout a liquid, not just at the surface. So we said that the escaping from the particles will be from the surface. Okay, but for boiling, it will take place throughout the liquid. Guys, you remember that we talked about something called the freezing point. The freezing point, we said, is the specific temperature at which the liquid would turn into, or change into what? Into solid. Okay, what about the boiling point, guys? Boiling point is the specific temperature at which this occurs in a liquid. Okay, so the specific temperature at which the particles start to boil is called boiling point. And for example, we know that the boiling point for pure water is equal to what, guys? It's 100 degrees Celsius. So once the temperature of all the particles in a certain container that contain a certain amount of water reach 100 Celsius or 100 degrees Celsius, they will start to boil, and then later on the particles will escape from the surface of the liquid, and now we can say that evaporation is taking place. Okay, so now, how does evaporation differ from boiling? Which of these processes is represented here? Actually, guys, the particles or the liquid here will not evaporate until all the particles of this liquid boil. So suppose you are now heating this liquid, and now you're adding what energy to this particle. So now the temperature of this particles is increasing from, for example, 25 degrees Celsius, then to 90, for example, degrees Celsius, and so on. So now the heat or the energy that you are adding to these particles will be absorbed by these particles, and specifically they will be absorbed by what? By the attractions or the attractive bond between these particles, and now the particles will be, as they are absorbing more heat, they will become more active and they will move more freely. So once the temperature reaches 100 degrees Celsius, at this point, guys, all the attractive bonds between these particles are broken, and exactly at this moment these particles will start to escape from the surface of the liquid. So guys, here we should know that you can't reach the evaporation until what? Until all the bonds, all the attractive bonds between these particles that are holding these particles in their position are broken. Once all the bonds are broken, then now the particles are more freely to move and to escape from the surface of the liquid, and then they will evaporate, and they will change into water vapor. So guys, again, for evaporation will not happen unless all the bonds between these particles are broken. And for water, for example, this will not happen until the temperature reach what? The boiling point, which is 100 degrees Celsius. So now, guys, what about the opposite process of evaporation? Can we turn or change the gas into liquid again? Of course we can. So as a gas is cool, its particles lose energy. So in order to change the state of matter from gas to liquid, we need to what? We need to cool this gas down, and here the particles will what? Will lose energy. So now the attraction between particles overcomes the speed of their motion, and a liquid forms. So exactly we have what? We have the opposite process of evaporation. This change of state from a gas to a liquid is called what? It's called condensation. So guys, again, if you want to change the state from gas to liquid, we need to what? We need to decrease the distances between these particles, so they can again form what? For the liquid, or give us the particles arrangement of what? Of a liquid. So here, to decrease the distance between the gases, we will what? We will cool down what? These particles, and then they will start to get closer from each other until they what? Until they form the particles arrangement of a liquid state, and then it will turn from gas into a liquid. So again, guys, when the state change from liquid to gas, this process is called what? Yes, it's called evaporation. What about the opposite direction? If we need to change the state from gas to liquid, it will what? It's called what? It's called condensation. In evaporation, guys, an amount of energy should be added. So here the particles are what? Are gain an amount of energy, while in condensation we need to what? We need to cool down the gas particles. So here the particles actually will what? The particles will lose an energy. So guys, we have this question here: what is happening to the water particles in each image? We have 3 images and we need to describe what is happening to the water particles, okay, in each image. So first of all, here, for example, we are adding what we are adding to ice cube. So what do you expect? What will happen to the particles of water here? Actually it will melt, because here the water is what is warm. So once you add the ice cube to this warm water, it will start to melt, and then the state of this substances, the ice cube will turn from what will turn from solid to liquid. Then as you are increasing the temperature of this water, as you can see here, you can see the bubbles, and the bubbles actually represent what? Represent the boiling process of water here. The water here is boiling, and then we continue, guys, the heating process. As we said, the bonds between the particles will break down, and then the water will start, or the particles of the water will start to escape from the surface of this liquid, and then these particles will evaporate. And as you can see here, the amount of water decreased so much as we reach the third image. Okay, so here we have melting process, and here we have the boiling process, and here we have what? The evaporation process. And after evaporation, guys, you can see that water vapor will what? Water vapor will start to what? Condense at the surface of what? At the surface of the cover, or at the surface of the lid here. So the water droplets that is forming here represent which process, guys? Represent the condensation process. So that's all for today, guys. Thank you, and see you tomorrow, inshallah.